This is the OR gate, part of our AOI logic. We did the AND in the previous video. And the OR is going to look similar to the AND, only we're going to have a curve here, graphically or schematically, however you want to put that. We're still going to use the same two inputs. Notice that there can also be 3-input or 4-input AND gates as well, or OR gates, or inverters are really the only ones that are single input. So this could have multiple inputs here, but for our sake, we're just going to go through it in this aspect. When you do an OR gate, I want you to think of it as addition. You're not really adding, but it kind of helps with the process of understanding it. So don't technically add, but I want you to sort of think addition. Here's why. Because when we speak, we want to say that we have A or B equals Z. Up here we had A and B, and it's kind of multiplication. A or B is going to be addition. Now I'm not going to say 1 plus 1 here is 2. That's not how it works in binary. But just think of it in this aspect. It's kind of a choice. Think of it, you can either have this or this to get that. So let's go through here. We have our truth table. We're going to input a 0. So let's say A is 0 and B is 0. If I have a 0 or a 0, my output is going to be 0. Here's where OR changes, right? If I have a 0 or a 1, my output is 1. If I have a 1 or a 0, my output is a 1. And if I have a 1 or a 1, my output is a 1. So no matter what, anytime one of these is a 1, my output will always be a 1. Or if they're both 1. The only time I will not receive an output of 1 is if both of these are 0. Let's see what this guy looks like in OR. I'll still go with what we have for Siemens. As far as our gates are labeled and concerned. Or I'm sorry, our IOs. So when we connect this, we're still going to have our output coil here. Alright, and this is our A, this is our B, alright, and A is still I 0.0, B is I 0.1, and our output is Q 4.0. Alright. Nothing changes as far as the addresses for what we're doing. But now we're saying in order for this to turn on, it can either be A or B or both of them. As long as one of these is turned on, this output will also energize. Now for the chipset, okay, if we have an 08 chip, it's going to look that's a 74LS08, it's usually a Texas Instrument chip. It's going to be very similar. It's going to still have 14 pins, only instead of little AND gates like up here on this red AND gate, over here, it will be OR gates. So each chip can hold up to 4 OR gates. If we're talking 2-input OR gates, I can put 4 OR gates on one logic chip. Next up, we're going to go ahead and take a look at an inverter.